An EMF 200 into exponential power minus 5t is applied to a series circuit consisting of 20 ohms resistor and 0.01 farad capacitor. Find the charge and the current at any time assuming that there is no initial charge on a capacitor. Observing this problem, we can easily understand this is a problem on CR circuit. Here first take the given data. Here they have given EMF E is equal to 200 into exponential power minus 5t applied to a series circuit consisting of 20 ohms. That means resistance R is equal to 20 ohms and the capacitor value is 0.01 farad. That is C is equal to 0.01 farad. Here we have to find the charge and current at any time assuming that there is no initial charge on capacitor. That means we have to find the electric charge, that is Q we have to find, and the current I we have to find. Here we have to find Q value and I value, assuming that we have to detect, assuming that there is no initial charge on a capacitor. That means initially the charge is 0. We have to find Q value and I value at any time t. Here, since this is an CR circuit problem, first you have to consider an differential equation of CR circuit equation, that is Ri plus Q by C, which is equal to E. This is a differential equation formula of CR circuit, that is Ri plus Q by C, which is equal to E, where R is a resistance and C is a capacitance, E is a electromotive force and Q is a electric charge, where I is a dQ by dt. We know that the current I is given by dQ by dt. First step, we have to substitute in the place of I as dQ by dt. We know that current I is given by dQ by dt. Substitute I value as dQ by dt. We get R into dQ by dt plus Q by C, which is equal to E. Next step, as before, we have to find the general solution for this differential equation. For that, we have to reduce this differential equation to a linear differential equation. Therefore, we have to divide throughout an equation by R. We get as dQ by dt plus Q by R into C, which is equal to E by R. Also, they have given a data E value, R value and C value. Substitute all the values over here. We get as dQ by dt plus Q by R is 20 into C is 0.01, which is equal to E is 200 into E power minus 5t divided by R is 20. So we get a value as dQ by dt plus here Q into 1 by 20 into 0.01, we get a value as 5, that is 5Q, which is equal to here this value becomes 10 into exponential power minus 5 into t. Now we can conclude this is a linear differential equation. So consider this as equation number 1. Therefore we can conclude that the equation 1 is a linear differential equation of the form dQ by dt plus P into small letter q, which is equal to capital Q, where P is here comparing the equation 1, P value becomes 5 and Q value is 10 into exponential power minus 5t. Once you obtain P and Q value, next you have to find integrating factor value, that is exponential power integral of P of t into dt. Substitute P value here, we get as exponential power integral of P is 5, that is 5 into dt. Here 5 is constant, take outside the integration of 1 into dt is t. Therefore we get integrating factor value as exponential power 5t. Next, we have to find the solution for a linear differential equation that is given by here. This is a linear differential equation of the form dQ by dt plus P into Q, which is equal to Q. Therefore we get a solution of an equation of the form Q into integrating factor, which is equal to integral of Q into integrating factor plus C. In previous problem, here in the place of Q we have I, because the linear differential equation of the form di by dt, but here this is of the form dQ by dt plus P into Q, which is equal to Q. Therefore we have to substitute as Q into integrating factor. Next step, substitute integrating factor value and Q value over here. We get as Q into integrating factor is exponential power 5t, which is equal to integral of Q is, here this Q value becomes 10 into exponential power minus 5t into integrating factor is exponential power 5t into dt plus C. Here the bases are same. If you add the powers, minus 5t plus 5t, that becomes 0. Exponential power 0 value is 1. Therefore we get a value as Q into exponential power 5t, which is equal to 10 is constant, take outside the integration. Remaining is integration of 1 into dt plus C. Here we know that this value becomes t. Therefore we get Q into exponential power 5t, which is equal to 10 into t plus C. Next step, take this value, that is exponential power 5t, to the right hand side, we get a value as q is equal to 10 into t divided by exponential power 5t plus c divided by exponential power 5t. Take this value to the numerator, we get q is equal to 10 into t into, if we take this value to the numerator, that becomes exponential power minus 5t plus c into exponential power minus 5t. Call this as equation number 2. So this is a general solution or an expression for charge. Here we get a value of q. Here next step we have to remove this constant value. For that, take a given data they have given initially, and that means at t is equal to 0, the initial charge is 0. Therefore, substitute q value as 0 and c value as 0 in equation 2. We get as, therefore substitute q value as 0 and t value as 0 in equation 2. We get as 0, which is equal to 10 into, here t value is 0 into exponential power minus 5 into 0 plus c into exponential power minus 5 into 0. Here exponential power 0 is 1. Here this value becomes 0. Therefore, we get a value of c as 0. Therefore, we get a c value as 0. Next step, we have to substitute c value as 0 in equation 2. We get a value of q. Substitute c value as 0 in equation 2. We get as q, which is equal to, here equation 2 is q is equal to 10 into t into e power minus 5 plus c into exponential power minus 5t. Substitute c value as 0, here we get as q is equal to 10 t into exponential power minus 5t plus 0 into exponential power minus 5t. This value becomes 0. We get a value of q as 10 into t into exponential power minus 5t. So we can conclude this is an expression for charge at any time t. We obtain a value of charge. Also, we have to find a value of current I. For that, consider a formula, that is I is equal to dq by dt. We know that I value is dq by dt. In the place of q, substitute this value, that is 10 into t into exponential power minus 5t. We get as I is equal to d by dt of 10 into t into exponential power minus 5t. The 10 is constant, take outside the differentiation. We have to differentiate this value, that is t into exponential power minus 5t with respect to t. We get as 10 into, here t is also function, exponential power minus 5t is also function. So we have to apply product rule over here. That is first function, that is t into differentiation of exponential power minus 5t is minus 5 into exponential power minus 5t plus the second function, that is exponential power minus 5t into differentiation of t is 1. Next step, we can take exponential power minus 5t as common over here. We get as I is equal to 10 into exponential power minus 5t. If we take as common, here remaining is 1, here remaining is minus 5t. Therefore, we get 1 minus 5t. Therefore, we can conclude this is an expression for current at any time t. So finally, we get a value of charge q as 10 into t into exponential power minus 5t. Using this value, we get a value of current as 10 into exponential power minus 5t into 1 minus 5t. This completes the problem.